Okay, guys, so classes and objects, finally. When you learn Java, it is so hard not to touch this topic so long, because everything is in Java are classes and objects. So we actually used already classes, but now we will talk about that, and we'll share why it is important, what that means for software engineering, computer science, what all of that means, object-oriented programming. Okay, a little bit of history and a little bit of definition. So object-oriented programming is a programming paradigm that organizes software design around objects rather than functions or logic. So do you remember that definition or that concept of structured programming? Yeah? So what the essence of the structured programming? What do you remember about that?
Simplicity and ability to make modules to then iterate them.
Yeah, make modules kind of with, first of all, use of what? Of methods, yeah. And we could structure our programs with loops, of course, conditionals, conditions, and so on. So an object in object-oriented programming represents a real-world entity with attributes, data, and methods behavior. Object-oriented programming allows for structuring programs by grouping related data and functionality into objects. So before that, we had just methods. Methods, what do you think? Methods are related to data or behavior? What do you think? Behavior, because it is method to do something, to execute. Exactly. And this is the difference between structured programming and object-oriented programming. Now we have not only data, or not only behavior, but we also could combine behavior with specific data, combine all of that into one object, and that behavior will be related to this specific data. In such a way, it is so easy to construct objects. Because when we talk about algorithms, about flowcharts, all our focus is processes, is algorithms, is flow of execution. It's very good, but there is no place for data there. There is no place for modeling entities. So for example, we have entity of student. What attributes and behavior could student have in information system? Okay, age, class, previous education. This is all data attributes. Okay, what behavior student could have in information system? Grades is data. Okay, yeah, so wake up, we'll come to class, like register in class, maybe with this, maybe you come to this building, you use your card, maybe information system could, I'm not sure if we have, I think we even have it now. So all of that, it is your behavior on the level of information system. So we somehow could group behavior and data about student, for example, or about teacher, or about hamburger in McDonald's, and everything, and so on and so forth, or about button in our web page, or in mobile application. So we could manipulate not just with algorithms, but also with objects, with real-world entities, which is a huge idea. Let me share a little bit history about that. So, first of all, let's jump. Don't try to kill your mind when you think about this syntax of unknown language. This is not the essence of this lecture, but just for you to understand that there are different syntaxes. And this is class vehicle, or vehicle, how to call it in English correctly? Vehicle. Okay, thank you. So we have attribute speed, and we have behavior accelerate. Data, method, and class, vehicle. So this idea of grouping methods and data together and manipulate them as with real-world objects was started in 1967 with language Simula. So after that, this idea was also developed with Smalltalk, this one more language. This language was fully pure object-oriented language. So we have another syntax. Yes?
Would you please share your screen? We don't see anything.
Oh yeah, I'm sorry guys. Yes, of course.
Thank you.
Yeah, thank you for mentioning that. I believe it is quite important. Okay. So Smalltalk, another variant, another syntax, but the same idea. Vehicle and speed and accelerate method and constructor method and so on. I will not like be very detailed. That historic details have no much influence to your daily activity as a software engineer and computer scientist, but that's quite interesting to know. Then C++, 1983, Strauss-Stroop developed C++, very popular language that's still used in many areas, especially in low-level programming. So we have same idea, class. By the way, C++ was like advancement of C with addition of these object-oriented features. So again, we have this speed attribute, and we have accelerate method, and we have this constructor which create this object, and we use this. Then that idea was adopted in pretty conceptual, philosophical way in Java. So Java became language which fully adopted object-oriented approach, and everything in Java is object-oriented. Even you can't even write a program with pure methods or functions. You should actually create class to create even hello world. So Java, this you see 1995 and so on. So then we could enumerate another languages like C# and modern web development languages like JavaScript, PHP, and so Ruby on Rails, and all of that languages implemented this object-oriented concept. So it became norm. So today, every kind of most of our programming utilize object-oriented approach. So this subject is very important. So let me jump into key principles of object-oriented programming and why it is so important. But before that, let me try to visualize one more time some class. So again, let it be student. This is our entity from real world, which we want to create model in our information system. And we have attributes. So of course, name, of course, last name, of course, maybe a specific ID. Every one of you have some specific ID, identifier, which identifies you, which unique number of your like student card and so on. Maybe program name or program ID, again, identifier, and so on. So this is our section with attributes. And then we have behavior. So behavior, for example, enroll to class. So imagine that you have, okay, this is first year and a lot of courses obligated to go through, but for example, you on the more like advanced course or your master student, and you have a lot of electives, and you could choose a course and enroll to that course. So for example, you have this behavior like enroll to course. And what else? Maybe, I don't know, so pass, send assignment. So it is quite like very fantastical methods, I could say, so very fantasy created, but nevertheless, we have some behavior of our entity. So this is a student, and we could create many students, and every student will have his own data, their own data, and their own behavior. And we could kind of work with each student specifically, and will not be combined and merged with other students. So imagine your program when you want to store data about many students without objects. How you do that? You will declare many variables. You have this one variable, another variable, then in your algorithm you think, or this variable related to which student, so you have no exact answer to that question. But here we could combine all the information, put that in the one place, and know exactly that all that information related just to this entity. So again, I will try to jump to this quite abstract concepts about object-oriented programming. But nevertheless, I will try to explain that. So encapsulation is the first idea of object-oriented programming. Idea of encapsulation considers that specific data like owned by this object, and no one in the outer world could accidentally access that data and break this data, break the idea or rules of how we store that data. So we can kind of close this data. So we could make this data private and outer world could not access that. But then we could provide public interface to that data, get ID, for example. And we could provide specific protected, let's say, secure access to that data, but under the hood, we could make some algorithmic calculations and conditions to know exactly that when we try to put something here, everything will be secure, everything will work correctly. So the idea of encapsulation, this is when we hide from the outer world some inner stuff. Like, okay, in our body, a lot of stuff hidden from the outer world, because we don't need outer world to contact my, now I have no this word in English, pachinka, nirki, heart, I know, so stomach, okay.
Liver.
Yeah, liver. So it is hidden, and we have specific members, organs to connect with outer world through specific interfaces, let's say, with specific like processes. So the same, maybe this is quite interesting example from biology, but nevertheless, so our entity has some inner structure. And we don't want to expose all that inner structure to outer world. Why? We don't want this. We want to protect that. And this is the idea of encapsulation. We protect inner data. Okay, next, inheritance. Okay, inheritance, this is something we will talk on the next lecture. But the idea is that we could extend our current class with the inherited class, let's say, child class, subclass, and say, for example, this will be master student. And this will be undergrad student or bachelor. And they will inherit all this universal data and behavior, but at some specific behavior and data related just to bachelor student and related just to master student, because we don't want to overload and to make this kind of God object and put everything here. We want to decompose that. But the idea that this master student will inherit all this behavior. So this is idea of inheritance. We will talk about that a bit later. Polymorphism, one more quite complex or hard idea, but not so hard actually. In that inherited objects, we could override some behavior. We could have methods which have its own implementation. For example, let's say that sending assignment for master students will require some additional steps and some additional algorithms, which is not needed for bachelors. And we could use the same method here and implement it differently. So that's why our object kind of changed their forms. Our methods could have its own behavior. So this is interesting idea of polymorphism. Again, this is quite advanced topic. We will talk about it later and maybe in next courses. And abstraction. Very important word in the world of computer science and software engineering, abstraction. Abstract thinking. You know that children under the, 7 years, they have no abstract thinking, as we say. Do you know this phrase? So, oh, he can't think abstractly. So if you're trying to joke with some child regarding your interest in fantasies and ideas, that child will get that very straightforward, right? So they have no that abstract thinking. What is abstraction in software engineering and computer science? Abstraction, this is idea when we reduce complexity of our objects from real world and choose just the most important stuff for our information system. For example, this student object, does this student object really represents correctly real student? Is it enough for you, these 4 attributes? I think you have thousands of attributes. But for our information system, all that attributes is not relevant, and we just don't need them. That's why we create abstracted version of student, which is reduced in that complexity, in that structures, and we kind of hide unneeded information. We hide and we abstract that information, and we say, okay, we don't want to bother ourselves about your maybe where do you live, what is your hobby, what is your eye color, and what is your favorite movie, and so on. We decided to be abstracted about that, and we think so. The same was the same like in biology, and the same in about like a person. So, for example, in UML, and by the way, this is UML class diagram. So this is not just drawing. And unified modeling language. In UML, we mark or we have this representation of user, like person, with this actual drawing. I don't know. So, of course, all of you know that, but this is official, not emoji, but how to say that? I don't know. So, icon. This is official mark for person. So, here we don't see not liver, not stomach, not heart, not even fingers, and no eyes, and so on. So this is abstract representation of person. So we abstract it and we just hide a lot of information because we don't need that information on this level of abstraction. So abstraction, this is concept of simplifying complex system by modeling classes based on relevant data and behavior while ignoring irrelevant details. Ignoring irrelevant details. Okay, this is a bit of philosophy. You have ethics, you have kind of philosophy course, so welcome to this philosophy thinking. But let's jump into additional details. So, I love this example. I love this example. This is engineering example because it is actual engineering and encapsulation is here. Abstraction is here. And information hiding is here. So let's think about that. So we have this, again, electricity. So we encapsulated a lot of specific important data or important structures under this socket. There is plus, minus, this additional ground, all that specific electricity stuff. Yeah, so all of that encapsulated And for the outer world, we expose it this interface. So you could consider that all that hidden here, it is there's specific data structures inside, or data. And what is exposed, it is specific, so methods could be also private, but some specific public methods, public interfaces to access that. And outer world could communicate, so we could communicate, this is outer world, we could call, let's say, method, and we communicate in by specific signatures, by specific interfaces of that methods, we communicate with this object. So it is everywhere in engineering. So when you come to the campus, you use this card. But you don't know details, how it works, what happened when you scan it, what happened in information systems. You have this abstract access, very simplified access to that very complex information system. So everywhere in our information system, we should use this encapsulation, information hiding, and abstraction. That's why object and classes kind of first step for that. Okay, now I want you to think, now it become interesting, yeah? So I want you to think and to consider this like a black box. We will recall that idea of black box many times in our software engineering related courses. So again, when you use your card, you come to that scanner and you use that information system as a black box. You don't need to know what specific configurations under the hood, how it works, what databases, where the servers, who configured that, and so on. You don't know that details. This is black box for you. But you know how to use that. You know interface, you know what is your input is card, what is output, doors is open. So this is approach of thinking about information system as a black box. So we could think about student object as about black box. So outer world should use very abstract, easy interface to communicate with this object, but all specific information structures, algorithms should be hidden and encapsulated here. So we should think about black box. We should not expose, we should not open our inner stuff to the world because it could be broken because of that. The same with this object. So this is just black box, and when we have many black boxes in our information system, we could decide how this stuff will work together. And on this level, we think about that black boxes very abstractly. Oh, we didn't know all the details, and we could cover all that complexity because we abstractly think about that. We know I want to come into the university campus with this card. You don't need to know which information system, which codes, which passwords, which database. You don't know all of that. That's why for you it is not hard to come to the campus. It's very easy abstracted task. So when we have many black boxes, we could build very complex systems. But if we expose all that configurations, and we rather have many specific small data algorithms and all that ifs and then and that conditions and loops and all of that big ball of mud, великий ком бруду, then all of that connected, you could not afford that complexity. You could not build good information system without this decomposition into black boxes. And let every engineer who works on black box decide how it works inside. And we decompose that and we build very complex systems. So idea of black box, very important, and all that encapsulation abstraction is used to build actually the black boxes and use all that black boxes all together and create very complex behavior, very kind of intellectual system. So let's come to now syntax and actual stuff. So class, what is class? What is class? So first of all, please remember, especially in the era of Gen AI, code generation, and so on, you need to understand your code. You need to understand these low-level concepts. So class, basically, is a custom data type. We have data type integer. We have string. We have array. And class with specific name, we create this name. One more data type, and that's it. This is just one more data type. But you create that data type. You decide what behavior, what attributes will be in that data type. You are creator of that data type. But class is actually just a data type. Second, class is a blueprint of or template for creating objects or instances of that class. So the same way as we create integer variable a, int is a data type, a is a variable. Int is a kind of blueprint for this integer. So this is blueprint, this is actual instance. The same with class. We have class, and then we create object of that class, actual student 1, student 2, student 3. That will be objects of the class. Instances or variables of that data type. And the main idea, I already expressed a lot of philosophical stuff here, my goodness, 10 minutes to 3, but now we just come to this idea. The main idea of object-oriented programming, it is just take attributes, take methods, and combine them in one data type. This is the main idea of object-oriented programming. So it defines set of attributes or properties or fields, all of that synonyms, you should know that, attributes, properties, fields, and combine that with behavior methods or functions or behaviors and create objects. So we combine behavior and attributes and we create entity or object. How it looks in code. This is it. So, for example, class car. What attributes do we have? Private string model. Let me comment on that. Private means that outer world have no access to this field. This is inner stuff of our black box. What type of that model? It is just string variable, and that's it. Then, speed. Another attribute, but of integer. And again, it is private, so it is closed for the outer world. Next, this is constructor. I will tell a bit later about that. Let's move directly to the method. So method drive, for example. So drive, you see the signature of this method. No arguments, no return value, just drive method. What is under the hood? Under the hood, we have access to private attribute, speed, and we just increment that somehow, like increment plus 10. So we accelerate our car, let's say, and we output some information to console. So pay attention that in the method drive, we access what? Our attribute, our data of our object, private variable of this object. So this is quite new concept for you, because before that we created variables, we passed that variables as arguments, but here we have this kind of global for this class. global for this object, everyone could access that private stuff or public stuff, like attribute stuff. And we access that. We do not create speed here. We just access that speed, and we change that. And then we have public, so again, public method. So outer world could access that. And the public string get model. Outer world could access and get model of our object and get speed of our object. Okay. So before I jump to the object, do you understand this idea of the class? Any questions on that? Yes.
There's this public car, it has no data type. What is that?
This one?
Yeah.
Okay, yeah, so exactly. This is constructor. Constructor, this is specific, special method in the class. This method being called automatically by the system when object being created. We create the object and automatically this constructor will be called. How to know that this is constructor? We have, pay attention to name, this name and this name. Do you see? So constructor have just the same name as a class. And we could pass any arguments to the constructor. So basically what we use, how we use constructor, just to initialize attributes. So you see, we have model, so we initialize model with this outer world argument. And we just put speed like 0 kilometers per hour at the very beginning when object been created. And we have interest in this here. And this is what I also should explain you, of course. So this just reference to myself. I could create many cars. I could create Tesla car, Mercedes, BMW, Ford. I could create many, many cars from this one blueprint. I could create one student structure, then create in my information system every instance of student for you. Okay? So I could create many, many cars here, but every car will keep their own attributes. So sometimes we could use these to reference specifically to myself. Why, you could ask? Because, pay attention, here I have variable model, argument, yes? But argument model and private string model have the same name, right? So if I not use this, how I know that I use actual this model and not this model? So if I put this, I will not mess with argument. Later I will back to this idea. Okay, hopefully you understand most of the things. So let's move to object now. Object. What is object? Very easy. First of all, first idea, please understand that object is a variable of class type. So I created my class, car, and then I declare object or variable of this data type. The same like with int a. This is variable of this data type. The same here. C is the variable of data type car. So C is just variable. And this is object. So basically, when we create variable of our class, we create object, and that's it. So this is first idea. Then, second, an object is an instance of a class. So this is quite the same, but with other words. Instance of a class. Next. It is a real-world entity that combines both data, attributes or fields, and methods, functions, and behaviors defined by its class. So, guys, first challenge for you who don't know object-oriented programming. you should differentiate basically. What is difference between class and object? What is different between class and object? Class is a blueprint. Object is a building created by this blueprint. Okay? I could have one blueprint like in Soviet times. So I live in a multi-level building. And I have in my districts maybe tens of that the same building, right? All of them just the same. Because all of them just created by the same blueprint. And even in Kyiv or in Ukraine, we have so many just the same buildings, multi-level flat buildings. So class blueprint is only one, but buildings actual, they are many. This is blueprint, this is class, and this is actual object. You should understand the difference. This is first challenge for you guys. What is the difference between object and class? And object is created using the blueprint provided by the class, and each object can have its own unique state. Okay, how it works in practice. So again, how to hide this stuff? I don't know. It's hard with Zoom. So somehow, let it be so. So you see the same class as we just saw, but pay attention when we create these objects. So we have one blueprint and we created two cars. So pay attention to this creation. Data type, variable, then initialization, using of new word. So every object created by new. We should use new because we create memory space for that. New, then name of the class, so basically name of this data type, and then call of the constructor. So we have this constructor and we have one argument. So we put Tesla here. This is model. We will put that into its own attribute. So we put that, and after this line executed, we have actual live object. This object is alive. This object is in memory. We could use this object. And we could even call methods of this object or access attributes of this object. So car1.drive. When we use strings, do you remember that? What methods of the strings do you remember? Yeah, equals, for example, yeah?
Substring.
Yeah. So basically, when you use string, you use objects. Because string is a class in Java. But you didn't know that until now. So string, when you use specific string and you call that methods is equal or substring or trim, you just call methods of this object and that's it. So the same is here, car1 drive. We just call method for this object. And we created one more object with the same blueprint but with different data. We pass BMW here and we call again method. So object is a variable, class is a data type. What questions do you have?
One question. This syntax is very similar to scanner syntax, like
Yes.
Like scanner, and so on. And maybe you said it before, but I forgot what does it mean system.in in scanner, because I think that scanner is also like class, right? Yeah.
Absolutely, everything is Java. In Java are classes, so absolutely scanner is a class. And when we create scanner, we call its constructor and we pass some data into that constructor. So this is the idea. Just scanner should accept specific way where to print everything. It is just argument, let's say. Argument for that constructor. But basically, this is exactly creation of the object. This is it. That's right. Okay, any other questions? Okay, so now we will have a break. So let's have a break. Let's have 15 minutes. So we will meet each other and 15 minutes past 2. Okay, so let's go on with our object-oriented stuff. So as I already mentioned, UML, and this is unified modeling language. And this is another visual representation of programming. We already touched flowcharts, which is representation of algorithms. This UML stuff was emerged as a response to huge changes in software development industry and emerging of object-oriented programming. So UML has a lot of different diagrams, but this is one of them, which is specifically related to our subject today. So UML class diagram. So I'm pretty happy that you already require it to draw something, like to draw charts, flow charts, to draw these class diagrams. So believe me, guys, in software development world, in computer science, it is so important program, first of all, of course, but also visualize, also communicate your design, also communicate your technical decisions. And we communicate that through visualizations like with these diagrams. So you're already familiar, and let me recall all I already presented here. So this is class. This is name of the class. This section, first section, devoted to attributes. Second section devoted to behavior methods. Then this minus or plus means either this attribute or function private, which could be accessed only inside the object, inside the class, or it is public, what means that it could be accessed from the outer world, like string is equal. This is public method. You access that method in the outer world. The same here. Oops. The same here. So plus means public, minus means private. And you see signature of the function of the method. So this is return value. Here could be arguments. And here you see the type of attribute. So basically that's it. And it's pretty easy to draw it, and then pretty easy to create code after that modeling or design. Any questions regarding UML diagram? Okay, so keep this diagram for yourself. You need it. Okay, a specific syntax stuff. Prior, my goodness. Okay. I already created today some channel in social network, and this is my second. What happened with me? R and T is together on the keyboard. So I already messed this letter in that private, in that social network creating channel. And now I see one more mistake. Okay, some dyslexic problems. I don't know what happened. So private, public, okay? This is first stuff you should understand. So I just showed you on the picture, and this is how it works. Private, public. This is access modifier. We call it like in definition of that term, the access modifier. So when you come to me or to TAs to show your code, we could ask you, what is that? What is private? What is public? And you could say, this is access modifier, and public means that, and private means that. We actually has also protect, but I will explain that later, what that means, protected. Next, constructor. Evgeny already asked me that question, and I explained what is constructor. So you see constructor here, the same name as the class, and the aim of the constructor is to initialize attributes of our object. this is a reference to myself. So I kind of feel that it is not enough of that explanation, and maybe I need to jump in and to extend that. But at this slide, let me recall that, remind, this is related to objects. So by the way, here we have it. We have two cars here, car 1 and car 2. For each of this car, we could, so for example, I could, okay, no difference, but anyway. So we call this constructor, we create object and constructor being called here. For each of these objects, car 1 and car 2, this constructor will be called. So in case of car 1, this will refer to car 1 object. In case of car 2, this will refer to car 2 object. So you should understand that when we create two different objects, we manage their data separately. Car 1 model and car 2 model. In case of car 1, which value of the model? So we put here Tesla. This is the value of this variable inside object car 1. And in case of car 2, BMW. So as you see, in both of these cases, we call this, and this here is a reference to this object, and here this is a reference to this object. So you could consider this like reference to myself. Okay, next, new. So again, like scanner, we already discussed that. To create new object, you use new, and syntax is this: new, class name, parameters for constructor, if any, or just empty brackets. Then member access. This dot means accessor, operator accessor. So for example, in different languages, we could have different operator accessor. So for example, in PHP, we have object, and to access model, we have operator accessor like this. So in most, for many languages, accessor is just dot, like here, object, member, like string, like string is equal accessor. So through this dot, we access inner stuff of our object. Where do you use that also? Do you remember? Strings, what else? You already used that accessor.
Scanner.
Scanner, right?
Next,
what else?
Y next state.
Random, yeah.
Next.
Yes. What else?
Integer parsing.
Integer parsing, yeah, like this big integer, right? So this wrapper, yeah,
Also,
this object, exactly.
Use integer minimal value for a certain value.
Yeah, so we see a lot of stuff. So you should understand that it is kind of access. Like, for example, some who want to be example, let me use someone of you, but asking Yaroslav. So for example, we have Yaroslav object. Some abstracted representation of Yaroslav in our information system, kind of abstracted, like simplified, but nevertheless we have. We want to access something from Yaroslav. You decide what it could be, some method. Let's decide. Record. I want to call method Yaroslav, please record the lecture. So I call method record. So you see, I call behavior of this object, kind of send message. When we call methods, also we could use this analogy, let's sending the message to the object. Check if that objects are equal. We kind of send, we ask that object to do something. So the same here, please record, yeah? I could pass some parameters here. So you could consider that like access to some inner stuff of that object. So when you use arrays, what do you use from that with accessor?
The value of the
Arrays.
index.
With accessor, with dot.
The memory.
Lens. You use lens every time you use lens. So array dot length. So please understand, everywhere where you use dot, this is kind of the doors to the object. So this is how it works. So actually, if I want to know Yaroslav surname, I will call Yaroslav surname. Maybe method, or it is public attribute. So you could consider that in such a way, okay?
If we want to access a public attribute, we don't have to place those.
Yes. If it is variable, you don't use brackets. If it is method, we use. So everything just like the same, like we previously worked. Yeah.
I kind of managed to forget. What is the dot code? What is
Accessor.
okay, thank you.
Operator accessor or accessor operator. Well done. I see one representative who actually have notes and have the definitions in his notes. Well done.
I will attest the people next to me whose screens I see, they are typing notes. So I'm not the only one. I'm just the only one who uses the
Okay, handwritten notes.
For
Okay.
me, I just will look the lecture a couple of times, hundreds. Even
Okay. Yeah. This.
Then if you're writing us like that
Yeah.
scene from
Yes. Exactly. Yeah. So. Yes. Basically, yes. So we should discuss also this static, what that mean, of course. So this is one more like explanation how to explain then static and what means instance method and class methods. This is one more explanation, but my idea is ask you just to read that because you have these reading materials. So let me remind myself what other, okay, this is just task. So let me experiment with you in just code, and let's try to do that and to run it somehow. All right. So I will delete this basic code. I will delete this code. So let's start from the very beginning. Of course, the name of our class will be what? Okay, let's decide what attributes will Yaroslav have. I don't know what the sense. We will have many Yaroslavs here now, so many objects of Yaroslav. That's pretty interesting. Maybe I should change that because this is cloning of Yaroslav program, kind of.
The implication was more.
We have one more Yaroslav in our group, so basically.
Yeah, but idea of classes, it is definitely that we have blueprint and we have many instances. So we should decide something, but we either create Yaroslav clone in factory here, or we choose another.
Don't worry about my clones. It's okay. It's okay. I agree with that.
Okay,
I'm giving my permission.
okay.
A million more on the way.
Let's call it like this, Yaroslav clone. So what attributes will that clones have? So let's decide all together. H. Okay, H may be 0. So because we will clone them very fast, and they.
Okay, so
But let it be.
chronological age, but biological age. So we can create an
All right, so many Yaroslavs in different age of his like periods of his life. That's okay. That's interesting idea. So yeah, what access modifier will we have with H? What your decision, Evgeny? You decide. Public. Okay. Public H. But what type? Integer. Right. Next, what else? This is biological age. Huh? Eye color.
Eye color can be different also.
What access modifier?
String. Sorry. Public also.
Okay.
Still you go to add like a
Is it correct spelling?
yes. Yeah. It's I color and color with you. It's American and British spelling respectively. So either one is correct.
Okay.
Can we?
Let's add one more attribute. Height. Okay.
Also public.
No, I want to have some differentiation. Let's use finally private something.
Private.
No one will know that.
We could provide interface to that. So
Private. Private dreams.
so int or maybe float, yeah. Private dreams. Okay. Height. IQ. Private. Yes. Secret information.
I mean, depending on how they're going.
Okay, so let it be. We have just 3 attributes here. Then let create constructor. So what should I put now? Like tell me what to do, and I will just public. Okay. Public Yaroslav clone. We could put some initializing parameters into our object. Okay. So what should I type now? Next symbol, let's say. Int h, exactly. So parameters. Okay. Now let's create body of this object. So what your proposals? What should I do here? So this h, because I could actually use h equals something like h, no sense, of course, because I take the same variable of parameter and assign the same value to the same variable. So this is not what I want. I want to take this exactly h of the object. So that's why I should use this. This could help me differentiate argument from actual attribute of the class.
So this is the one that is public.
Yeah, but it is no different. Yeah, public. Okay, so this is the one that is object, basically. So again, string, access, operator, and something. Here, we don't know how programmer will call this Yaroslav clone. It could be any variable name. But inside the object, we just call ourselves this, myself. Okay, let's move on. So it seems we should do the same with other stuff, right? Okay, so we took these income parameters to our constructor and assigned them to inner variables of the class. Okay, let's bring some behavior to our clone. What it could be? Yeah, record. Okay, we will have many clones and all of them will record from different positions. That totally makes sense. Why, of course, I don't know in this picture, why do we need to know eye color or height, this details?
No, what we are so you need to like.
Which I was wondering about, is it like common to go backwards? Like you first kind of understand the methods for your class and then find attributes? Is that a thing or not really?
Yes. Of course, that could be difference, but we create black box. Good question. So we create black box. And we know that this black box should do in some way, we don't know how, we will think about that later. But we want to know what interfaces will this black box have. So record, maybe, I don't know.
Like modeling.
Yeah.
Oh, modeling.
So we create this public interfaces, and that public interfaces is actually public methods. So yes, it is good way of thinking about design. Okay, record will be private or public? Why public or why private? In this black box, will we call from outer world that record? This is our public interface, how to interact with objects. So that's why record is definitely public. This is our way to our black box. So I don't know about parameters, so maybe, yeah, what problem here? Void, of course. Return value. So maybe we have no other, like we have no return value. Let me just output something. Yes, yes. Okay. What else do you think? Increase age. Biological age. Okay. Let it be. Not a problem. So again, public, right, or private? Hmm? Okay. Age. So then int, yeah. Int and let me call it like this. Become older, for example. We could pass parameters if you want. For example, how many years do we want to add, or maybe just increment by 1? Any ideas? Just increment. Okay. Now, what should I write here? Age. So we decided not to use argument because we decided to use just, yeah, by the way, why not to do this? And we should return, for example, return that age. So this is the behavior of this method. Okay. Okay. So maybe we should also have like method stop recording. Or maybe method, let me, how we use it actually, publish to YouTube, for example. Let me use this. Publish. Oops. Okay, this is it. Yeah, that's interesting that Yaroslav clones have the same names. Yes, so all of them will be Yaroslav. So how we will differentiate them? Maybe surname?
By
Okay.
surname. I mean,
What-
clones are usually differentiated by a serial number and or a nickname. If
Index of
Okay, let's have serial number. What do you think if we generate serial number? What do you think about that? That could be great idea, yes? So remind me how to do that.
First import. You need to import.
this can be Java to
Math, Java utils, okay.
It's actually when you're just using random is
Yes, I agree with that. So let me, then what? Random. I should create object or what? I just don't remember. Yeah, maybe here I don't need seed, right? Or I need. Huh?
What are the seed and the bound?
Mhm. Okay. Okay. Hopefully it will work. So
Counter the seed and the bound. Like everything. What are these words?
this is inner stuff like so bound. I believe this is our like. Okay, let me jump in. Yeah, I believe this is just upper limit. So, what is that? Next int range from 1 to. So, I could even do not use any arguments and have just any number. Let's say so. This is basically good for us. So we could even do like this. Will also work. So this is polymorphism of random objects. So I could call different with the same method, the same kind of behavior method, but different variations of that. Okay, so when we create clone, that clone will get a random serial number. That's pretty interesting. What else do you want to have? I want to have how to know serial number. So look, this is private. This is private stuff. I don't want anyone change the serial number. That's why this is private. But if I want to know the serial number, how to get that? Yes, exactly. We provide interface for that. So public int get serial number. Bless you. And we just return actual serial number. This is our object. Now let's create.
We have a question. I think in the example you showed before, you did the model by first doing like model, this model, and then you return it. Why don't you do that here with the serial number?
This, you mean this?
Yeah.
Yeah, good question. So I actually can do, and this will bring the same result. But at this point, this is 100% that this serial number, if I even click that, it will refer to my inner attribute. Why I use it here? Because it is not clear, because I already have H here and H here. So in this, in current naming area, H is referred to argument. So if I want, in this case, to refer to actually attribute, I need to add this differentiation, so this attribute. So yeah, if I have this, for example, h1, then I could use h equals h1, because h1, different name, h, there is no h in this method, there is no h in arguments, that's why compiler goes to h of the current class. This is the idea, you see? Okay. Right, so let's create objects. Yaroslav clone, and then variable name. So let's call it Yaroslav1, and we create new. So we call objects from, we use variables, I like for convention from small letters, so Yaroslav1, new, and again class name. Class name, and then parameters. Okay, so what are our parameters? h1, okay, this is error here, so that's why. So h, let's decide, you decide. What should I type here? 30. Okay, quite mature, Yaroslav. Next, what do we have? Eye color. Okay. And next parameter, height. Yeah, we can, of course. So which, in meters, yeah? Okay. Okay, what the problems here? Yaroslav clone. Okay.
You forgot writing height. You need to take the F.
At the end?
And yeah. But if we don't writing a public float get height, because my code is dumb and wrong.
Okay, so one more time. What the problem?
We need get height basically. Public float get height.
Yeah. Yes, 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 but still it should work. So because okay, so this is just warnings, I believe. Remove this useless assignment to local. Yeah, I have some specific. I use additional like stuff which may give me warnings about clean code. So okay, forget that. So let's just use it. So Yaroslav 1. Okay. Record, I believe. And then Yaroslav 1. Publish, and I would like to have serial number. Get serial number and make it more beautiful, this output. Serial of number 1. Okay, Let's run it. So, lecture recording is started. This is when we call this record method. Lecture is published. And we have this serial. This one, with minus. Okay, because we actually need to add maybe range here. Let me run it one more time. Yeah, it's more beautiful. And one more space when output produced. And run it again. Yeah, it looks better. So, but this is just one first object. So let's create a few more clones. Yaroslav 2. Which age? Eye color. Height.
Let's be some abnormality.
10 meters, okay.
Yeah.
12 years old with blue eyes, okay. And yeah, and again we call that methods, and we should have another serial number. So we have actually two objects now, and now we create one more object.
But serial number in your Yaroslav 2 get serial number.
Yes, serial of number 2.
No,
Ah, right. Yes, yes, you're correct. This is typical problem when you copy and paste your own code. Exactly. Everywhere I should refer to correct object. Object 3. Object 3. Object 3. Object 3. Object 3. So object 3, which age?
90. Purple. Violet.
Hey,
0.5.
how many?
0.5.
0.5. My goodness. Okay. So this is what we have. We have object with this serial number, we have object with another serial number, and object with another serial number. So we have three spaces in memory with their own variables, and we manage that variables and algorithms related to that variables in one place, which is very useful, which is really good. So you could actually use objects in such a way. And of course, it is better to create basically class in specific additional files. So for example, Yaroslav, clone. Yes, I created this file, and then I will move this code. Where is that code? What? Here. Recursion. Okay. Yes, wrong place. So I create a new class here. Again, Yaroslav clone with the same name as class name. This is how we do it in Java. So we have a specific place for our class. Then I will just delete that from here. Delete it from here.
Cut.
Yeah, cut. And then I put it here. But I should add, if I'm not mistaken, public. Yes. So to make this class accessible from the also outer world, because there are some rules for for using modules, like let's say, so what the problem here? And I should import that class now. Import not recursion. So I have some problems with my IDE now. Oh my goodness, what I just did.
Yeah, there is like class public, not public.
It's kind of funny that this.
But I just created. Where is that class?
Yeah, it's here. It's class public.
Finally, we gained that point when students teach me. So this is what I basically want to achieve. Okay.
Class public in the code. It should be
Yes.
class public.
Yes. So class and objects, and so what the problem?
No, public class, not class public.
Ah, right.
Order.
Exactly. Yeah, this is that fantastic moment. Okay. Okay. And what? So hopefully, it finally will work. What the problem now? Yaroslav Clone. Oh my goodness. So I don't need to import because I'm in the same package. That's why all of that stuff is visible here. And because of this class is public, so I could, so you always, when you create a file for your class, that class will be public because you want to use that class in different files of this current package. You just keep your class and object package name everywhere, package name here, package name in other files. So, but this is very good because you now have your black box, Yaroslav Clone. This black box just store it in a separate file. And you could create that, and some developer could work on that, and you just have public interface to use that black box. But inner algorithms being created by that specific developer. Even if it is you, still, you could concentrate your work only on Yaroslav Clone, inner stuff, encapsulation. But then in outer world, you just use black box. All you need to know just public methods, public attributes, and that's it. So this is how we use classes, and it really helps us to create our complex systems.
Yeah, but we have these two files in the same folder. But for example, if we have like main in another folder, let's say recursion or something, how do we import it? Do we type
Yeah,
import?
you kind of import like here. So you use your package name dot that class name.
So show us. Show us how you do it.
We could use import from recursion. Import. Because and I could use Yaroslav Clone from here. So I could have two files in different. This is also kind of polymorphism I could use, but this is name. So that's why we could have local names, let's say, and will not be afraid, oh, I create some name of the class which is already used somewhere, but because of these packages we could easily configure or manage naming, let's say. Okay, any questions? Now, I want you to work, I will give you quite long task, but I believe you could easily afford that. So